Okay, so in this video, let's talk about integrated rate law. So firstly, let's take a look at zeroth order reaction. Let's take a look at the reaction. Simple reaction. A moles of A react to itself to form B moles of B plus C moles of C. So we can write the instantaneous rate. We know the instantaneous rate is negative 1 over A times the derivative of the concentration of A with respect to time. And we also know that the rate law is equal to K times the concentration of A to zeroth power because of zero order reaction. That means uh, K times A to zeroth order is just K self because uh, A concentration of A to zeroth order is equal to 1. So let's take a look at how do we get integrated rate law. Well, first we need to times A on both sides. So we get negative the derivative of A respect to T times A times K. And A times K, we define A times K as Ka. Then we can use separate variables. We times dt on both sides, and we integrate on both sides. So on the left side, the integral of dA is just A. We integrate from A naught to AT. A naught is a concentration of A at time when times equals 0. AT is concentration of A at any time. That is equal to AT minus A naught. On the right side, since Ka is a constant, when we integrate from 0 to t with respect to time, the answer for the right side is just negative Ka times time. We can plus A naught on both sides to get this form. And as you can see, this form is in the form of a linear equation, a linear function. So the t is same as x here, b the y-intercept same as A naught here, and m the slope is same as negative Ka. Y in this case is just At, which means we can make a graph. The graph of the concentration of uh, the A and time. So as you can see, because this is in form of a linear function, the graph is linear, and m the slope is negative Ka. Remember, K is positive. A must be positive, of course, because it's a coefficient. So Ka is positive. So negative Ka is negative. That means the slope is downward sloping, is negative. All right. So let's go to next slide. Okay. So the let's talk about first order reaction now. So okay, hold on. Okay, so the first order reaction, well, is equal to, well, first order reaction in this case is we use a reaction AA. The A moles of A react to itself to form B moles of B plus C moles of C. So the instantaneous rate is this expression on the left side, and the right side is the rate law. It's the first power because it's a first order reaction. So let's get integrated rate law. Let's solve the state pressure equation now. Times A on both sides, K times A is Ka. All right, separates variables. We divide by the concentration of A on both sides and times dt on both sides. We also move the negative sign on the right side too. Let's integrate. On the left side, this one is just the integral of 1 over A. And integral of 1 over A is natural log of A. On the right side, since Ka is a constant, it's same as before. It's negative Ka times T. If we integrate from 0 to T, it's also Ka times T. On the left side, we integrate from 0 A naught to AT. So on the left side is equal to natural log of AT minus natural log of A naught, which is equal to a negative Ka times T. Well, that means, what does that mean? That means if we plus natural log of A naught on both sides, that's equal to natural log of AT equal to negative ka times time plus natural log of a naught. Well, what that means? That means, 1 second. Okay, so that means the we can also see it's also in the form of linear equation, linear function. So t is x and negative k is still n. But in this case, y is not at. Y in this case is natural log of at. So in this case, we can graph for x-axis is time. For y-axis, we can graph put natural log of a, the concentration of a, and this is also a linear relation. So in this case, m, the slope is negative ka. So the slope is downward sloping because k is positive. All right, the last one is second order reaction. Well, of course, there's not just three types of reactions: first order, first, second order, and zeroth order. They can be third order or half order, but we only talk about three types of or reactions now. So still we have a very simple reaction. A moles of A forms B moles of B plus C moles C. We can write instantaneous rate on the left side and rate log on the other side. Remember, this is second order reaction, so it's K times A to the second power. Again, we times A on both sides. K times small a is Ka. Separate variables, as we did before, and we integrate. Well, what is the integral of 1 over 1 over a squared? Well, the integral of 1 over a squared is just negative 1 over a. And on the right side, it's the same as before. It's still negative Ka times t. And as you can see, in this case, we have negative sign on both sides, so we can make both sides positive now. We integrate from a naught to at. What we get is 1 over at minus 1 over a naught, which is equal to Ka times time. Plus 1 over a naught on both sides, we get 1 over a t equal to Ka times time plus 1 over a naught. Well, as you can see, in this case, t is still x, but what's different is that in this case, m, the slope is Ka, not negative Ka. And y is 1 over a t. So if your graph is 1 over a versus time, well, as you can see, the slope is positive in this case because slope is just Ka, not negative Ka. So it's a linear and the slope is positive. So remember, for all three situations, if you don't know Ka yet, what you can do is for each one, because we have a linear relation, we can calculate, like for zeroth order reaction, we can do delta y over delta x, and for zeroth order reaction is just delta a, the concentration of a over delta t. But for first order reaction, because y is natural log of a, you need to do delta natural log a over delta t. And for the last one, the slope is delta 1 over a over divided by delta t. And you need to pay attention that we're calculating slope now. So you need to know what is the relation between slope and Ka. For first order and zeroth order, slope is negative Ka. But for second order, remember, slope is just Ka. All right. Sometimes in tests or exams, you might be given a graph of a linear graph, and they might ask you, say, well, by the graph, what's if you just look at a graph, what is the reaction order? Well, if the graph is linear and it's upward sloping and it's 1 over a versus time, well, that's definitely second order. If the graph is downward sloping linear, but it's the graph of concentration of a versus time, well, that's zeroth order. What if is the graph of natural log of a with respect to time? Natural log of a versus time, and the graph is linear? Well, that's definitely a first order reaction. So, hope you liked this video. Thanks for watching, and have a great day.